In this example, we'll be finding the measures of angles. Find the measures of angles 1, 2, 3, and 4 in the figure, given that lines M and N are parallel. Let's examine this and notice that we are told that angle 1 is 3x plus 2 and angle 4 is 5x minus 40. The next thing is that angle 1 and angle 4 are called alternate exterior angles. And that means that they are equal to each other. So one piece of information is that angle 1 is equal to angle 4. Next, what about angle 2? Well, relative to angle 1, they form this straight line. And that means that angle 1 and angle 2 are supplementary, and that means we have an equation angle 1 plus angle 2 equals 180 degrees. And finally, what about angle 3? Well, angle 3 is a vertical angle to angle 1. So therefore, angle 1 is equal to angle 3. So that's the information we're going to use. Now let's go back and start with our first relationship, angle 1 equals angle 4. That means that we have 3x plus 2 is equal to 5x minus 40. And what we then need to do is to solve this equation for x. So let's do that here. And so now, we have x's on each side, so let's subtract the 3x from each side and at the same time add 40 to both sides. So we have 42 is equal to 2x. Now, dividing both sides by 2, we get 21 is equal to x. Now, that's just the value of x. We need to substitute that back into our expressions to find the actual measure of the angles. So this angle, 3x plus 2, would be 3 times 21 plus 2. And when we simplify that, that is equal to 65 degrees. Now, of course, if we were to substitute the 21 in here, we better come up with 65 degrees. And, in fact, we will. 5 times 21 minus the 40. So that would be 105 minus 40 is 65 degrees. Now, let me make a note. This one is angle 1. This one is the measure of angle 2. Let's put colons instead. Now we need to find the measure of angle 3. Well, if you recall, when I discussed, I'm sorry, this is angle 4. My mistake. Angle 4. Because angle 1 and angle 4 are equal because they were alternate exterior angles. Now, let's find the measure of angle 3. Remember, angle 3 was a vertical angle to angle 1, which meant that angle 1 is equal to angle 3. Well, we just said that angle 1 is 65 degrees, and that means that angle 3, or the measure of angle 3, is equal to 65 degrees. And now for angle 2. Recall that we said that angle 1 and angle 2 are supplements. That means they add up to 180 degrees. So therefore, angle 1, which is 65 degrees, plus angle 2 is equal to 180 degrees. And now subtracting the 65 from each side, we find that the measure of angle 2 is equal to 115 degrees. So our angles are angle 1, 65 degrees. Angle 2, 115 degrees. Angle 3, 65 degrees. And angle 4, 65 degrees. In this example, we'll apply the angle sum of a triangle property. The measures of two of the angles of a triangle are 48 degrees and 61 degrees. See the figure. Find the measure of the third angle x. So here we have x, the angle that we're asked to find, and we have a 61 degree angle and a 48 degree angle. What we know is that the sum of the three angles of a triangle add up to 180 degrees. So our equation would be 48 degrees plus 61 degrees plus x is equal to 180 degrees. And now let's solve that here. So what we have then is 48 plus the 61 for a total of 109 plus x equals 180. And now subtracting 109 from each side, x is equal to 71, and that is degrees. So therefore, the third angle measures 71 degrees. In this example, we'll find the measures of angles in similar triangles. In the figure, triangles ABC and NMP are similar. Find the measures of angles B and C. So looking at the triangles, angle A corresponds to angle N. And as you can see, they're already marked as 45 degrees and 45 degrees. So now for angle B, it corresponds to angle M. Angle M is 31 degrees, and therefore angle B is also 31 degrees. Angle C corresponds to angle P. Since angle P is 104 degrees, then angle C is also 104 degrees. In this example, we'll be finding the lengths of the sides in similar triangles. Given that triangle ABC and triangle DFE in the figure are similar, find the lengths of the unknown sides of triangle DFE. Well, let's again notice that angle A corresponds to D, B to F, and therefore side DF corresponds to side AB. We need to know that because in similar triangles, the corresponding sides are in proportion. And so therefore we can set up a proportion where we compare DF to 24. So let's do that. DF over 24. And that would be equal to, and now we can take this side DE that corresponds to this side AC and say that it's equal to 8 over 16. That will allow us to solve the length of DF. What about EF? Let's set up that proportion. EF corresponds to the CB. And therefore, what we can say is EF divided by the 32 is equal to, and we can use the same exact ratio, 8 to 16 for the other side of that proportion. And now we want to solve each of these proportions, so let's do that here. So, to solve for DF, we want to cross multiply. So we have 8 times 24 is equal to 16 times DF. That means we divide both sides by the 16. This would be 192 in the top divided by 16 is equal to DF. And when we do that division, we find that DF is equal to 12. And that means the length of side DF is 12. Let's do the same process to find the length of EF. We'll cross multiply. That yields 8 times 32 equals 16 times EF. Multiplying the 8 times the 32 and then divide that by 16 will give us that EF is equal to 16. And therefore, the length of EF is equal to 16. We found the two unknown sides. In this example, we'll use a proportion to find the height of a flagpole. Firefighters at the Morganza Fire Station need to measure the height of the station flagpole. They find that at the instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 99 feet long. The station is 10 meters high. Find the height of the flagpole. Let's point out that the station and its shadow are measured in meters, whereas the shadow of the flagpole is measured in feet, and therefore we'll be finding the height of the flagpole in feet, and that it is okay to have different units of measurement when we're working with a proportion. Let's take a look at an illustration of the station and the flagpole. Here we see the station, which again is 10 meters high, casting a shadow of 18 meters. And at the same instant, the flagpole of unknown height casts a shadow of 99 feet. And so to set up the problem, we're going to use a proportion where the side MN corresponds to the height of the station. So we would write MN divided by 10 is equal to, now we take this side, 99 is 218. Now let's solve that proportion. We have mn over 10 equals 99 over 18. One thing we can do is to simplify the 99 over 18 because 9 divides into each of them, giving us 11 here and 2 here. So what our proportion becomes is mn over 10 equals 11 over 2. Now we cross multiply. 2 times mn, 2 times mn equals 10 times 11. That's 2 times mn equals 110. Now we divide both sides by 2, and we find that mn is equal to 55. And that means that the flagpole is 55 feet tall.